Okay, guys. This is my dashboard, right? So first, we're gonna start with the overview section. So welcome to the very first page or the section of my dashboard, right? So this overview tab actually introduce our primary study area along the Golden Road corridor in Mount Lavinia, right? So this primary study area covers 5 GN divisions, as you can see here on the map: Mount Lavinia, Matrapula, Cowden West, Wathamulla, and Vidikanda, right? So at the top, 7 KPI cards give a quick kind of a baseline about our study area. So we have 5 GN divisions: land area, population density, total housing units, and housing density likewise, right? So with the population, you can see it clearly shows this kind of a highly urbanized area, right? Urbanized kind of a settlement. So built up area is around 92, so most of land is already developed, right? So housing units, it actually shows housing pressure and the urban form, right? So if you click a GN division on the map, right, as you can see, the dashboard is updating. Also you can select from here, right? Likewise, after selecting, you can get the back to overview. If we click this button, it means it already, it directs to the default version of the dashboard, right? Considering all 5 GN divisions. So likewise, we can select from here, likewise, right? So actually a key feature, then we can talk about the real-time environmental condition, real-time data integration, right? It's one of the key features. Uh, and we connected two open Meteor APIs, free publicly available APIs, right? The first API is actually weather forecast API. So you can see here, this is the official website and this is the API docs. So you can see here API URL and all the weather models as well as API endpoint V1 forecast. We use this and a lot of parameters are there. And yeah, so first one is, like I said before, the forecast API, right? So it sends actual latitude, longitude, as well as a time zone, right? And it returns temperature, humidity, as you can see here, wind, rainfalls, feel like temperature, UV index, and 24-hour forecast, right? So second one is actually air quality, right? So this is the second one. So again, you can see the open API URL. We use this and documentation V1 air quality. Previous one was V1 forecast, right? So it returns USAQI and PM 2.5 the same location, right? So by default, their loads for actually the study area center, right? We actually took Mount Lavinia, right? Coordinates. So when you click anywhere on the map, as you can see here, see it's updated, right? So this panel actually auto updates in 10 minutes. So when we, like I said before, when you click anywhere on the map, both APIs are refreshing for that exact point, like exact same point. So below that, I'm gonna make it quick, right? Actually, I have another video explaining all the things in very, in detail version. Actually, for this overview section, it got 30 minutes, so you can see. I got a lot of the explain, but assignment criteria and all that says that we should finish this in 5 minutes. Actually, I can't do that, right? To be honest. So you know why. And the population trend. So these are census years 2001, 12, and 24, right? The latest one. So this shows that population change is kind of not a uniform one, right? All the GN divisions population are decreasing with the time. So then land use distribution. Before that, you can see this fab menu, right? So you can toggle on off any layer you want mentioned in here. See rows, POIS. If we land use, toggle on land use, you can see the same color codes are implemented. So you can see when you move your mouse cursor, residential, likewise, you can get a nice idea, right? So home, as percentage, you can see 63 residential area, right? So it's kind of urbanized. It's kind of a residential wise, kind of a compact city. Area, right? So as well as commercial activities are happening, as well as public space, likewise, grounds, recreational facilities, all the things are mentioned here. So then actually the population structure, this is the one we actually selected at this moment. So it compares with the primary study area average, right? So you can see these are changing, right? So we can get a nice understanding about the age wise, whether they are a lot of children, adults, or working force, likewise, right? So all the peoples likewise. So and then age dependency balance. So here there are two main parts: child dependency and elderly dependency. So yes, the dashed margin is study area average. So when you click something, you can get nice understanding about, okay, so this is the, I mean, child dependency is more than the average area, right? This water when it comes to water apple area. So then road wise analysis, right? So here you can see actually we took all this data from municipal council, right? So you may be wondering what's this shows. Actually, let's say if we click this road, right, road wise we can get an understanding, as well as road, not actually road wise, right, left right, wise, side by side. Actually the original data we took from 140 municipal council data, right? So that was a huge data amount. Actually we have to, like, I mean, first we thought like we should analyze all of them. I mean we should analyze, I mean, it's kind of a time consuming work, right? You can say those data files, they are here. Sorry, actually the challenge was 140. There are a lot of tables, lot of, actually columns are the only fixed one, 8 columns, and the rows are like 80 to some exceed over, 100, right? So these are the tables we got. So if we analyze one by them, it takes a huge time. So that's why we I created this script using Python, so we can get extract all the data, right? Residential wise, okay, percentage. Let's say Templars Road left side, okay, 60% of residential, and how many properties? Likewise, we can analyze it, right? So that was the main kind of actually, this script saves a lot of time, right? It actually kind of very one of the most, I mean, proper decisions we got. So this is our data set actually. All the data from census reports and all the credible sources, not AI generated one, right? So here's actually our property list, right? So raw dice, this is what we get as the final I mean result of my script, Python script, right? You can see there are, actually this is kind of reusable, right? For the future, considering future, situation, if we get more like this, I develop for them actually. So exporter, dashboard, parser, likewise. So this is the result. You can see residential wise, we can analyze how many properties, right? How many properties, see, and then we actually uh, I put the longitude and latitude coordinates, so we can indicate through this map, right? So actually the reason for these dotted ones and the see the segment ones are actually dotted ones are, although we give longitude and latitude to the OpenStreetMap, it can identify, right, that segment is not uh, identified. So that's why we actually put a point so the users can understand, okay, this is about, this road, right? So you can see there's no road name actually. So that's why we took these from Google Map, all the coordinates, but here we chose the OpenStreetMap. That's the case actually. So road wise analysis, residential, commercial, Balan. You can see actually we took 65 roads, right? Like I said before, we got 140, but it covers actually whole DMMC area. But to this analysis, we took 65 main roads where commercial centers are dense and residential area are dense likewise. So here the road ranking: residential most highest percentage, commercial, and the vacant. Vacant land actually gives us a kind of a better understanding about what are the roads that can be used as, future development. Actually, bare lands means future development potentials. Oh yeah, so that's it. I guess I explained everything, right? So let's we move to the focus area.